that I'm recording. Okay. I can see my transcript, so I'm recording. Okay, so let me go back to the exercise that we were doing. Is this exercise? So the network per se is this one. Let's keep it all the time with us here. And let's see the next exercise that we have to do. So let me open another file. And in the last slide, give us the next exercise. So last time we did exercise 5, task 5. Let's try to do task 6. So look at what task 6 say. Let's read that. Okay, so task 6 say what? Let's see. It say block ping to firewall from anywhere. So which means that from when I try, I'm going to try to ping from PC1 to firewall, it should not work. From PC31 to firewall, it should not work. And from PC2 to firewall, it should not work. Nobody is allowing to ping the firewall. This is one of the first things that a hacker will do. It will try to ping your machine to see if your machine is up. And if your machine answers the ping, it means that it's up. If it doesn't answer the ping, it doesn't mean that it's not up, no? It might be filtered. This is what we want to do. So the hacker will have doubt if the machine is up or not, because the machine will not answer a ping. So how ping work? Can somebody tell me how ping work? What protocol do we use when we use ping? Do we use UDP? Do we use TCP? So ping is there is a protocol that is called ICMP, Internet Control Message Protocol. On ICMP, I have a lot of type of message. So the type that are used by the ping utility are ICMP echo request, ICMP echo reply. So the client send an ICMP echo request, it arrives to the destination machine, and the destination machine send an IP echo reply message to the client. And we do that several times, the number of times that you have said. So let me put the network again. Let me start the devices. So I'm going to start PC2. Start PC11. Start PC31. And the firewall. Okay, they will take some time to boot because I boot them all at the same time. Let me open the console. Okay, all the consoles are open. And I want to wait for PC2 to finish booting so I can ping to another device, for example. And we can study the ping utility. We choose ICMP. So I enter as root and type tour as my password. And I'm going to do a ping. Let's say that I want to do a ping to PC11. So the IP address of PC11 is 172.24.0.11. So I'm going to do ping -c, the number of echo requests that I want to send. Let's say I want to send 2 echo requests to PC11, which is 172.24.0.11. And I'm going to capture. So they will go from here to here. So I can capture in this link or in this link or in both links. But with one capture, it's enough to study the protocol. So I'm just going to capture, for example, here to make it easy. And we are going to see the ICMP echo request, ICMP echo reply. So we will see that 2 times because I say 2 times. So I'm capturing in this moment. Let me execute the command. The first one, the second one, let me stop. So look at here. We have as protocol, we have ICMP. And this is ICMP have several types, as I was telling you. This is an echo request. So the echo request go from 192.168.0.2, which is PC2, to 172.24.0.11, which is PC11, as you can see. So this is the echo request. We can see it here. Source IP address 192.168.0.2, destination IP address 172.24.0.11. And if I look inside the ICMP message, you will see that we have a type. So here we have something that says type. So the type is 8. And type 8 corresponds to an ICMP echo request. Then follow with that, we have an ICMP echo reply. So let's see. Of course, the echo reply is going to go from PC11 to PC2. So the source IP address have to be 172.24.0.11. So look at it here, 172.24.0.11, and it's go toward PC2. So the destination IP address have to be 192.168.0.2. And as you can see here, the destination IP is 192.168.0.2. So this is if I open the IP header field. Now, of course, inside the ICMP protocol, we will have a type, and this type will be echo reply, and echo reply is 0. So if you look here, we have a type, and the type is 0, and 0 corresponds to an echo reply. So we have an ICMP echo request that goes from PC2 to PC11, then a reply that goes from PC11 to PC2, then another request, and then another reply, and we are done. Because I say do that 2 times. So it's why my capture only have those messages: ICMP echo request, ICMP echo reply, ICMP echo request, ICMP echo reply. Okay, so the exercise tell us, let's see, where is the exercise? It is there. It states we want to block the ping to firewall. So no PC can ping the firewall anymore, because in one PC I might have an hacker, so I don't want to give information to the hacker if the computer is up or not up. So we need to write some rules in the firewall. So let me enter all the devices. On the firewall where we are going to write the rules. Okay, so let's verify that in this moment we can ping. And then we will show that after applying the rule, we will not be able to ping. So I go to any PC and I'm going to try, for example, to ping the firewall. So if I want from PC2 to ping the firewall, what command can I write? So ping the number of echo requests that I want to send on any IP address of the firewall. So it can be, for example, 172.24.0.1. Okay, 172.24.0.1 is this one. So in this case, I'm pinging from PC2 to this IP address of the firewall. And of course, it will work because there is no filtering. I can ping to the other address, which is 192.168.0.1. And of course, it will work. So as you can see from PC2, I can ping the firewall. Let's try also from PC11. So this is PC11, the window of PC11, and I'm going to ping. Let's do 3 times. I'm going to try to ping the firewall. So for example, 172.24.0.1. First time, second time, third time, it's work, as you can see. And I'm going to ping the other IP address of the firewall, which is 192.168.0.1. And it will work. First time, second time, third time, and it works. Okay, now in the firewall, I want to apply some rules so I cannot ping the firewall at all from any other devices. So here I'm in the firewall. So the first thing that will be nice is to verify that what you think we should verify. That we have no rules, okay? That the firewall is totally open to let all the traffic in this moment. How can I verify that? With which command? So IP tables dash numeric verbose list. So it tells me that we have 3 chains. the input chain, the output chain, and the forward chain. And as you can see in the tree chain, we have no rules. So in the input chain, we have no rules. In the forward chain, there is no rule. And in the output chain, there is no rule. So what do you think? If we want to filter, we are configuring this firewall and we want to protect the services that it offers. So we want to protect the firewall. We want to block the ping. If somebody tried to ping me, to ping the firewall, I want to block. So what chain do you think we should use to put a rule? The input chain, the output chain, or the forward chain? The input chain, exactly. One PC2 send me an echo request. It's an input for me. Then when I send the echo reply, it's an output for me. So we are going to block we are going to put some rule in the input chain. So let's do it. IP tables. So when I want to append, I use the capital A. I want to append to the input chain. What should I append? So I want to block what? The ICMP. What do you want? What do you think we should block? So let me tell you again. When PC2 ping the firewall, PC2 send an ICMP message. And the type of this message is echo request. It sends it to the firewall. And the firewall answer with an ICMP message. And this message, its type is echo reply. And it's go from the firewall to PC2. So which one of the two I need to block? Because I'm blocking on the input chain. Which one should I block? The ICMP echo request or the ICMP echo reply? The request, because it's an input to me. The request is an input to me. The reply is an output for me. So I need to block the ICMP echo request. Okay, so do I need to specify the IP address of the devices that I'm going to block? So we want to block from any IP address, from any remote IP address. We don't want to allow ICMP echo request packet to arrive to the firewall. So if I use the -S for source, what should I put here? What IP address should I put? Yeah, we should put 0.0.0.0, but this is an IP address. I need a whole network. So, because when you put an IP address, it's a specific device. For example, if I put 192.168.0.2, I am blocking only PC2. But I want to block all the IP address of the world. Nobody can ping the firewall. So I need to give a whole network. And a network is a network ID / a prefix length, or a network ID / a net mask. So here we are missing the / 0. So I can put 0 here, or what else? 0.0.0.0 will be the same. Okay, so I want to block all the IP address. For which protocol? So you have the option -P. Here I can say, for example, TCP. I can say UDP, but there is an option to say, I want to block ICMP. Now, if I just let like that, it will block all the ICMP message. What I want to block is the message that have type echo request. So there is an option that is called --ICMP type. And I'm going to say, I'm going to block the echo request. Which type I want to block? The echo request. Oh, let me change the terminal. So export, because it doesn't allow me to write it well. Term equal ANSI. I think with ANSI it will be okay. Okay, so let me write it again. I want to append a rule in the input chain. So I want to filter from any IP address. the protocol ICMP, and what kind of message of ICMP I want to block, what type. I want to block the echo request, Okay, what else is missing in this command? -J for jump, what I want to do. What is the action I want to do? I want to drop them. I don't want to accept them. I want to drop them. So I put a rule. Now, if I type the command to see what are in my tree chain, you can see, for example, that the forward chain is still empty. The output chain is still empty. Now, in the input chain, we do have something. So look, for ICMP, that come from this space, with that come from this source, sorry, that come from everywhere, and the type is 8. The ICMP echo request is 8, the type is 8. ICMP echo reply, the type is 0. I will drop them, as you can see. Let me show them to you again. I will drop them, no? All the 8 which are ICMP echo requests. So now if I go to PC2 and I try to ping again, so the previous ping did work. Look now. It doesn't work. You see? I tried 2 times. So let's wait the ping to end. So it's doing the first and second intent. It did say, okay, I tried to send 2 ICMP echo requests to the destination that you specify me. I didn't receive any ICMP echo reply back. So the packet loss is 100%. And look, I'm going to type again this command. So if you look here, the number of packets that have been doing match with this rule before I execute the ping command was 0. Now it should be 2. So let me type it again, and you see there is 2, saying that I did receive 2 ICMP echo requests and I dropped them according to the rule that you program me to do. So now PC2 cannot ping the firewall, PC11 neither. So look, I'm going to try to ping from PC11. It's not able to ping the firewall. And if I look here, I will arrive to 5, of course, no? 2 plus 3 are 5. So 5 packets have matched this rule and were dropped, as you can see. So now I'm filtering as they ask me to filter. Nobody can ping to me. That doesn't mean that from the firewall I cannot ping the other one. From the firewall I can ping the other one. So let's see. I'm going to go to the firewall. Here we have the firewall, sorry. And I'm going to try, for example, to ping PC2, and it will work. So ping 192.168.02. As you can see, it worked. What I don't want is people to ping myself. I don't want people to ping the firewall, but a user in the firewall may ping remote devices if you want to see if they are alive. It's a way to verify if a device is alive. Okay, so this is a possible rule. So there is another possible rule. Okay, I want to remove this rule. I want to remove this rule. What can I do to remove this rule? What command I can do to remove this rule in the firewall? IP table dash flush. Flush is remove all the rule. There is only one. We could do delete, rule number 1. Delete, for example, in the input chain, rule number 1. This is the first rule. So it will just remove the rule. As you can see now, we are empty. We don't have any rule in the input chain anymore. So in this case, we could have write something a little different. For example, we could have write maybe 2 rules. If we write 2 rules, one that does not allow the traffic from this network and another one that does not allow the ICMP traffic from this network, what can we write? For example, let me block PC11 and PC31 from doing ping. So in this moment, since I remove everything, PC11 and PC31 should be able to ping. So look, PC11 is able to ping. PC31 should be able to ping also. Let me increase the font. Let me do a ping with 2 ICMP echo requests. And we are going to ping, for example, 192.168.0.1, which is one IP address of the firewall. And as you can see, it's work. So I want to block these 2 devices to do ping to the firewall. What rule can I write in the firewall to do that? So I'm going to append an input rule, which means in the chain input, I'm going to append a rule. So what should be the source? I want to block all the devices that are in this network to do ping to me. So I'm going to specify the whole network. So it will be 172.24.0.0/16. And what is the protocol that I want to block? ICMP. If I just stay here, I will block all the ICMP protocol. It's not what I want. I want to block the ICMP protocol that have a type that correspond to echo request. Echo request. And when I have a packet that match this rule, what should I do with it? I need to drop it. So after writing this rule, I should be able to ping from PC2. Let's verify it. Let me increase the font. So here we are in PC2. We should be able to ping the firewall. As you can see, we can ping the firewall, but from PC11 and PC31, we should be blocked. So here it's PC11 trying to ping the firewall and it cannot. And this is PC31 trying to ping the firewall, and as you can see, it is blocked. It's cannot. Okay? So as you can see, the ping here fell with 100% of packet lost, and here also the ping fell with 100% of packet lost. The 2 ICMP echo requests that I sent did not have an ICMP echo reply as an answer. So I block the traffic here. Now, if I want also to block the traffic from this network, because they were saying block the traffic from everywhere, what can I do in the firewall? I can add a second rule, and this second rule will be what? I also want to block the traffic in the other network. So the other network is what? Is 192.168.0.1.0.0. So if I look at the rule that I have 2 rules. And look at the first rule, already have 5 packets that match, which is the previous ping that I did from PC11 and PC31. Now, of course, if I try from PC2, I should be blocked. So let me do it 2 times. And as you can see, I'm blocked. And if I look here, I should have 2 the next time that I execute the command. So to make it a little smaller, I can just say, show me the rules of the input chain. And here are the rules of the input chain. So we have 2 rules. We block these networks on this network to do ICMP echo request to me. And as you can see, I've blocked 2 in the network where PC2 is, which is the 192.168.0.0/24. I've blocked 2 messages that did match the rule. Okay? Okay, let me remove those rules. How can I remove those 2 rules with only 1 instruction? So I can do flush all the rules that are in the input chain. So now if I ask, show me the input chain, it is empty. You see? It's showing me the input chain and there is no rules anymore. Okay, now I want to do the same, but instead of blocking the ICMP echo request, I want to block the ICMP echo reply. So give me a rule that I can type here to block the ICMP echo reply. So let's see again. When PC2 ping the firewall, there is an ICMP echo request message that goes from PC2 to the firewall. And the firewall answer with an ICMP echo reply that goes from the firewall to PC2. So the one that I want to block is the reply. I want to drop the reply. So I will receive the request. The computer will process and we prepare the reply, but when it passes through the firewall will drop it. So at the end, I will not send a reply. So the ping is not going to work. So what kind of rule can I write to block the reply, let's say from this network? Give me a rule that will block the reply, the ICMP echo reply from this network. The reply that go toward this network, I should say. So we can tap IP tables. We are going to append a rule in which chain? In the input chain, the output chain, or the forward chain? The output, because the echo reply is an output for me. It goes from the firewall to PC2. So I'm going to say I want to block on the output chain what kind of traffic? So the one that go toward the network where PC2 is. So toward the network 192.168.0.0/24. Okay, the one that go toward PC2, the network of PC2. And what protocol do I want to filter? The ICMP protocol. On what type of ICMP that I want to filter? I want to filter echo reply message. So echo reply. Instead of writing echo reply here, I could have written 0. Because an echo reply is correspond to 0. An echo request correspond to 8. As you could see it here, 8. This 8 that appear here is the type of ICMP message that I want to block. So now it's what is going to appear here, it's a 0. So what is the action or the jump? The action is to drop them. So now I am blocking PC2, but PC11 and PC31 should work. So let's verify that PC2 is blocked to do a ping. You see, it is blocked. Let's verify that PC11 can do it. As you can see, it can do it, and PC31 also can do it. So PC31 can do it. So as you can see, one who were blocked, PC2 cannot ping now the firewall. Not because the firewall dropped the echo request, but the firewall this time dropped the echo reply. Is it okay? Okay, let's try to do another exercise. So we just did exercise 6. Let's do exercise 7. Block ping from PC11 to PC2. So now I'm going to block. PC11 should not be able to ping PC2. So let's reopen the firewall, which means that I don't want any rule in the firewall. Let me clean the firewall. So in this moment, the firewall have one rule in the input chain. So I'm going to remove this rule. And this rule, if we have one rule in the output chain, sorry. If we have one rule in the output chain, it will be rule number 1. So I'm going to delete rule number 1 in the output chain. So now if I show a listing of the tree chain, they are empty. So of course, from PC11, because we want to block the ICMP, the possibility to do a ping from PC11 to PC2. Notice that you should be able to ping from PC2 to PC11. So let me go to PC11 and see that we can ping PC2. So here I'm in PC11 and I'm going to try to ping PC2. So let me ping it two times only. The IP address of PC2 is 192.168.0.2. And as you can see, we can ping it. So after putting some rule in the firewall, we should not be able. And of course, from PC2, I should be also able to ping PC11. So what is the IP address of PC11? Let me copy it here. So let me show you that we can ping. From PC2, we can ping PC11. Okay. Oh, I forgot the number of times that I want to ping, or the number of ICMP echo requests that I want to send. First one, the echo reply came. Second one, the echo reply came. So I show message of the statistic, the round trip time, statistic of the round trip time. So from PC2, I can ping PC11, and from PC11, I can ping PC2. So now I want to block the possibility from the person that is in PC11 to ping PC2. So of course, this packet is going to pass through the firewall. So the firewall can block it. So when PC11 ping PC2, there is an ICMP echo request message that goes from PC11 to PC2. And then there is an ICMP echo reply message that goes from PC2 to PC11. So we want, for example, to block the echo requests that go from PC11 to PC2. So give me the rule, please. What should I write here? To block the ICMP echo request from PC11 to PC2. Okay, here we can see all we need to see. So what should I type? So I'm going to help you at the beginning. IP table dash. Okay, this is the help I can give you. I want to block the possibility to do ping from PC11 to PC2. But remember that we should be able from PC2 to ping PC11. That will be the forward rule. Why? Forward rule is when I receive it on one interface and I forward it to another interface. So I have to append a rule in the forward chain. Okay, so what else should I put here? We need to give some criteria about what kind of traffic we want to drop. So what flags should we put here? So for example, dash S, what should we put with dash S? The IP address of PC11, because we want to say the packet, the source IP address have to be this one. So of course, if we want to block PC11 to send something to PC2, the source have to be PC11. So we are going to put here 172.24.0.11. We want to, the packet that have this source IP address, we want to block. What else we need to specify? Very good, dash D. We need to say the destination have to be PC2. So we are going to put 192.168.02. Okay, if I do that, what will happen if I just stay with that? I block all the traffic from PC11 to PC2. I don't want to block all the traffic. What I want to block is the possibility to do ping from PC11 to PC2. But from PC11, I should be able to telnet PC2. I should be able to secure shell. I should be able to see the web browser of PC2, because we are not going to filter this traffic. We want to filter the possibility of doing a ping. So what else should I write? So first, dash P is to specify the protocol. So when we specify the protocol, we can put HTTP, we can put TCP, UDP, ICMP. Those are possibilities. So here, what should I put? What kind of traffic I want to block? ICMP, Internet Control Message Protocol. I want to block the ICMP. Now, the ICMP per se have many types. So ICMP echo request is one type. ICMP echo reply is another type. If I just put ICMP, What will happen if I just put ICMP? Will I be able to ping from PC2 to PC11? I will not be able. So I just want to block the possibility to do ping from PC11 to PC2. So I need to do what here? Dash dash ICMP type. What is the type that I want to block? I want to block the echo request packet. So the action, the dash J, the action is to drop that. Okay, let me see my rules. I'm just going to see the rules. Numerical, verbose. My rules in the input chain. There is one, oh, in the forward chain, sorry. Because this is the forward chain. There is only one rule. No packet have matched the rule for now because we have not generate packet from PC2 to PC11 to match the rule. So let's do it. I'm going to go in from PC11 to PC2. I'm going to go on PC11 and I'm going to try to ping PC2. So previously it was working. So this time it should not work. So as you can see, it doesn't work. So if I look here, I should have two packets that matched the rules. We have two packets that match the rules, as you can see. Now I should be able from PC2 to ping PC11. So here we have the command to ping PC11. The IP address of PC11 is 172.24.0.11. It should work. As you can see, it works. So we did filter the possibility to do a ping from PC11 to PC2. And we let open the possibility to do a ping from PC2 to PC11. So you saw how we wrote this rule? It is still there. So you can see it, no? So we say that the source is 172.24.0.11. The destination is 192.168.0.2. The protocol that I want to filter is ICMP. Which type of ICMP message that I want to filter? The echo request. And all the packets that match this rule must be dropped. This is the action. So all the other packets will be accepted, no? Because look at the default policy is to accept, which means that if what will happen when a packet arrives and this packet is to be forwarded? We will go look in the forwarding chain if the packet match a rule. So we go to the first rule, we see if it match or if it doesn't match. Let's say that it doesn't match. Let's say that there is a second rule, it doesn't match. Let's say that there is a third rule, it doesn't match. And there is no more rule. If there is no more rule, we will do the default policy. And the default policy is to accept them. Okay? So if there is no match with the rules, we go with the default policy. If there is one match, the first rule that do match, we do whatever the action is. So the action can be dropped. The action can be accepted, for example, no? Okay, so we solved this exercise. Let's see now what exercise they have for us. So we just did this one. So let's do 10, task 10. Block the ping from the firewall to any remote destination. So now when I'm in the firewall, I should not be able to ping PC11, and I should not be able to ping PC31, and I should not be able to ping PC2, but they should be able to ping me. So we want to block any possibility from the firewall to ping the PCs. Okay? So let me first clean the forwarding chain. So let me clean all of them. So how do I clean all of them? The tree chain. Dash F. If I don't specify flush, if I don't specify any chain, it will flush the tree chain. So now if I look at the tree chain, the input, the forward chain, and the output chain don't have rule anymore. Okay, so from the firewall, I should not be able to ping PC2, PC11, and PC31. So let's see that for now, we are able to do that. So I'm going to go to the firewall. Here I'm in the firewall, and I'm going to ping 2 times, for example, PC2, 192.168.02, and it should work. As you can see, it worked. I should be able to ping PC11, so 172.24.0.11, and it works, as you can see. I should be able to ping PC31. The IP address of PC31 is this one, and as you can see, it's work. So I need to type some rule in the firewall, so I cannot ping PC2, I cannot ping PC11, I cannot ping PC31. So let's do 2 rules. One rule that will block us to ping PC11 and PC31, which means block us to ping to this network. And then we will put a second rule that will block us to ping to the network where PC2 is in. So what can I write to block any possibility to ping from the firewall to PC11 and PC31? What rule can I write? So first of all, every time that you write a rule, you need to think, is this traffic generated by me? The IP table host. Who is the IP table host in this moment? The firewall. Is this traffic is generated by me? If it's generated by me, it's the output chain. So is this traffic is received by me and must be consumed by me? If it is the case, is the input chain. Or is this traffic just pass through me? If the traffic just pass through me, it will be the forwarded chain. So in this case, we want to block the possibility to ping from the firewall to PC11 and PC31. So that will be what? What kind of traffic for the firewall? It will be output, because we are going to send an ICMP echo request packet to PC11. So that will be output traffic. At least the ICMP echo request will be output traffic. So I'm going to type IP table dash add a new rule in the output chain. What should I write? So I want to block all the devices that are in this network to receive ICMP echo requests from me. Exactly. So the destination that I'm going to block is the whole network, which is 172.24.0.0/16. Instead of writing /16, we can write 255.255.0.0, which is the same. Okay? And it accepts the 2 syntaxes, the dotted decimal notation and the / notation. Okay. What else do I need to write? So if I just write that, what I'm blocking is what? Any traffic from the firewall to the network, to the devices of the network 172.24.0.0/16. It's not what I want to do. I want to block a specific protocol, and this protocol is ICMP. Now, do I want to block all the ICMP message? No. I want to block a specific type of ICMP message. And those messages are what? The echo request. So look, instead of writing here echo request this time, I'm going to not put echo request, I'm going to put 8, because I know that echo request is 8. So of course, it's a little more clear writing echo request. You don't have to memorize that echo request is 8. And what is the action is to drop them. So now what does it mean? From the firewall, I should not be able to ping PC11 and to ping PC31. So let's verify this. So this is the IP address of PC31. Look at operation not permitting. Okay, so it does say that there is a filter that doesn't allow me to do it. And of course, now if I look at the rules, I'm going to list the rules. So I'm going to do numeric, verbose, list the rule. There are 2 packets that tried to go out and were dropped. Now I'm going to try to ping PC11. So instead of 31, let me put 11 here. And also, as you can see, the traffic is blocked. So when I will look at the rules, I will have only 1 rule, and this rule will have 4 packets that have been doing match. So let me see the rule, in particular the output rules, and as you can see, there are 4 packets that went out, did match with this rule, and they were dropped, because this is the action that I want to do with those packets. Now I should be able to ping PC2. So let's see that I'm able to ping PC2. Should have the, here it is, the instruction to ping PC2. And this one should work because I didn't filter it for now. So it does work. So now let's put a second rules. So let me show you the rules again. You see this rule? If I do an append, this rule will be rule number 1. And the new rule that I'm going to append will be rule number 2. So if you want to see the rule number, remember that you have the option line number. On line numbers will show you the rule number. So here I say rule 1. The first rule will be rule 1. So it did add 1 field in the table of result, is to show me the rule number. Okay, so now I want to, and by the way, you remember that I put a 8? It is there, no? So if I will have to put it a little bigger. So when I type this, I see ICMP type is 8, the one that I'm filtering. Okay. Okay, now I want to block the possibility to do ping from the firewall to this network. So what? I need to add a second rule. So let's do IP table -A. It has to be in the output table. So what should I put? The destination will be any IP address in 192.168.0.0/24. So either I write 24 or 255.255.255.0. So what is the protocol that I want to filter? ICMP. What kind of ICMP message I want to filter? So we have ICMP type. We want to filter type 8. Or if I don't want to type 8, I put echo request. We want to filter the echo request. So what is the action? I want to drop them. Okay, if I type this line as it is, it will be the second line. So if I want to put it as the first line instead of append, I can use the input. So the insert. The insert will insert it as the first line. So let me do the insert this time. And let me show you the rules. So look at the second rule that we have append was inserted as the first rule. You see, this is the second rule that we have append. And the one that was previously there, that was rule 1, now is rule 2, because I inserted a rule before rule 1, so rule 1 become rule 2. So now let's try from the firewall to ping PC2. And in this moment, we have 0 packets that did a match. When I try to ping, let's do it. Ping to PC2, let's do 3 times. So I'm trying to ping to PC2 3 times. So as you can see, we do have a message saying that ping didn't work because the operation is not permitted because the firewall is blocking that. As you can see, we have a loss rate of 100%. And when I look at the rules, so the first rule, which block the ICMP echo request toward this network, have 3 packets that didn't match and they were dropped because the target is to drop them. Okay. Now, does it mean that from the firewall, I cannot secure shell PC2? It doesn't mean that. So for example, PC2 have a secure shell server. Let me try to secure shell to PC2 and it should work. So secure shell, I'm going to try to enter as the user John. John at 192.168.02. So as you can see, it's telling me, oh, I just bring the public key of PC2 and the fingerprint of the public key is this one. Do you want to accept it? Yes. So it's telling me what is the password of John. Let me put John pass because this is what we put. John. Did we put John pass? Yes, isn't it? Oh, we don't put John pass. So maybe John capital PASS. Okay, I don't know. I don't remember which password we put in. Oh, did we create the user John in PC2? I don't remember. So we can check it. Let me go back to PC2. How can I check the user that I created in PC2? How can I check if user John is there? So for example, one possibility, ID John. It does exist. So what will be another possibility to verify that John exists? For example, check if it has a home directory. It does have a home directory, as you can see. Another command to check if John exists is to check if in the file etc password, there is a line for John. As you can see, we have a line. It's called John Montgomery. So I don't remember his password. How can I change his password? So we can then do the secure shell. So I can use the command password John. Let me change the password of John. So it's going to tell me I am the administrator. I have all the right. It doesn't tell me what is the previous password of John. It just tells me what is the new one that you want to put. So I'm going to put John pass. G-O-H-N, capital P-A-S-S. G-O-H-N, capital P-A-S-S. So now, let's do that again from the firewall. I should be able to secure shell as John. So the password P-A-S-S, capital P-O. The password is John, G-O-H-N, capital P-A-S-S. And as you can see, I am John in the computer PC2. So I was able to secure shell. So the fact that you block ping doesn't mean that you block secure shell. I can secure shell, but I cannot ping PC2 because this is what we put in the firewall. We want to block the ping. Okay, let's see another exercise. But I hope this time you help me to solve it totally. So we just did block ping from firewall to any remote destination. Block ping from firewall to PC2. This means that from firewall, I should not be able to, if I try to ping PC2, I should be blocked. But from firewall, I should be able to ping PC11 or to ping PC31. From PC2, they should be able to ping firewall. So the only traffic that I want to block is the possibility to do a ping from the firewall to PC2. As they say, no, block ping from firewall to PC2, no? This is what we are doing, exercise 11. So before we start, I want to start with a brand new firewall, a brand new IP table with empty table. So what should I do? IP table dash flush. Flush the tree chain. So now if I list the tree chain, numerical verbose, they are empty. So all the traffic is allow it. So for example, let me see that I can ping PC2. So ping 192.168.02. And as you can see, I can ping PC2. So let me now put a rule that is going to block me to ping PC2, but just PC2. I should be able to ping PC11 and PC31 after putting this rule. So what rules can I write? So if I want to block the ping from the firewall to PC2, for the firewall, it will be what? What kind of traffic? Will it be forward traffic, output traffic? The ICMP echo requests are going to be output traffic. So I'm going to write IP tables dash add or insert in the output table. What should I insert? So I want to block the ICMP echo requests that go toward PC2. But if there were another PC in this network, it should be able to go. I want to block the one that go toward PC2. On the destination. So I want to block the IP packet that go toward this destination. So dash S is source IP address. Dash D is destination IP address. So if the destination IP address is 192.168.02, I want to block that. But here I will block all the traffic from the firewall to PC2. That's not what I want to do. I want to block the possibility to do ping. So what should I block? I need to say what protocol I want to block. If you don't say the protocol, it's you block all the protocol. There is a possibility to dash P all, which means I block everything. If you don't specify the option dash P, it will be I block all the protocol. I don't want to block all the protocol. I want to block ICMP. Now remember, within ICMP, we have many types. So we want to block a specific ICMP type. And what is this specific ICMP type? The echo request. We want to block the echo request. So what is the action that I want to take with the packet that match this rule? I want to drop them. Okay. So let's see the rule first. So as you can see in the output chain, we have run rule. And for the packet that go toward this destination that are ICMP echo requests, we are going to drop them. Okay, so which means that now I should not be able to ping PC2. So let's verify that. So this is a ping to PC2. It doesn't work as you can see. Okay, I should be able to ping PC11. Let me try to ping PC11 because we didn't block the traffic, the ping traffic toward PC11. So 172.24.0.11 should work. And it works as you can see. Or toward 31, PC31, it works as you can see. Oh, from PC2, I should be able to ping the firewall. So here I am in PC2. Let me try to ping the firewall. So ping 192.168.01, and it should work. And it works as you can see. So I did what they asked me. I blocked the possibility to do a ping from the firewall to PC2. All the other traffic is allowed. Okay. Let's see what other exercise they want us to do. So, block web access from firewall to any remote destination. So, which means that if I'm in the firewall, I cannot access the web server of PC11. There is a web server. The web server of PC31 or the web server of PC2. So no web traffic will be allowed from the firewall to PC to the other PC. But the web traffic from the PC to the firewall should be allowed. So it's like I have employees here in my company and I don't want them to access the web, because when I allow them to access the web, they go to Facebook, they check their bank accounts. I don't want that. I want them to be in the company to be working. So I'm going to block their traffic toward the internet. But of course, I have web server, so I want the people in the internet, my client, to access my web server. So let's block the possibility from the firewall. So Robert and Michael that sit in front of the firewall should not be able to access the web server of any remote destination. So before we start, let's clean the firewall. Let's have an open firewall. So I'm going to flush all the rules, and I'm going to verify that I have nothing. So it's totally open, the firewall in this moment. It allows all the traffic, because as you can see, the default policy in input is accept. The default policy in forward is accept, and the default policy in output is accept. And we have no rules in the input chain, in the forward chain, or in the output chain. Okay, we could type only one command, but let's type one command that will block the HTML traffic, or will block the user that are in firewall to access the web server that are remote in this network. Then we will make a second rule for this network. So if I want to block here from firewall, I cannot access the web server. What should I write? Okay, I write part of the command. Give me the rest. So, sorry?
Could you just repeat the question one more time?
So we want to block the possibility from firewall to access the web server that is in PC11 and PC31. So as you can see, we have a web server here and we have a web server here. So in this moment, I can access it. So for example, let's see that I can access it. I am in the firewall and I want to access the web server of PC11. What can I do? What command I can do? So last time we see a command that is called elinks. You remember? Elinks -- dump, show me the web page that is in the web server that is in the IP address 172.24.0.11. Dump, sorry. So this is the web page. It's a little long. So as you can see, Debian logo, we can even customize it. Let me customize it. So we are in PC11. I'm going to edit var www HTML index. And it's a little long, so let me make it much shorter with the first paragraph. Oh, it's very long, yeah. Okay, so this is, we are going to keep up to this. So all the rest I want to drop it. So let me drop this paragraph and everything that is after that. Okay, let's drop this. We have a bunch of things here. Let me see if we can manage to reuse that. We don't want all this too long. Maybe I just do my web page. Okay, so let's do I do my web page very easy. So we start with HTML head. We put a title and we put a paragraph. That's it. So you are familiar with HTML, no? We just put a paragraph. Wow, it's so long. This is the default web page of Apache. Now I went too far away. Head and head. Let's put a paragraph. So Apache Debian default page. It work. Let's see. Let's put from PC 11. And let's put a small paragraph here. We don't need all this. Okay. Nice to respond your query. Okay, so let me do it again from the firewall. We are going to ask this web page again to see, should just say what we have. Nice to respond your query. So the head, just put title, or maybe header one. Let's put header one. Header one and header one. Very small one. So as you can see in header one, we have Apache Debian default page. It works from PC 11. And nice to respond your query. So let me copy that. So as you can see, we were able to access the web server in PC 11. Let's verify in PC 31. So the same thing, in PC 31, they have a long web page. So I'm just going to reduce it, var www HTML index. I'm going to remove everything. It's empty. And here, I'm just going, the only difference here, I'm going to put PC 31. So look, from the firewall now, if I do it in the IP address of PC 31, so it's work from PC 31. Let's do it in PC 2 also. To have a long web page, let's put it shorter. So HTML index, let me remove from line 1 to the end, to the last line, delete. You see this editor VI is so powerful. And here we are going to say PC 2, and let's say something different. I am in Jacksonville, for example. I am in JSU. Okay, so when from the firewall, we try to reach PC2, it have a web server 192.168.02. So it say we have a header one. Oh, I did PC2 here. I am in JSU. Okay. So as you can see, we can access the three web server. From the firewall, we can access the three web server, the web server that are running here, here, here. So they say that you should block all possibility from the firewall to access the web server. So help me with that. So remember, we have an empty, we have no rules in the tree chain. So I want to block the possibility from here to access the web pages that are here. What should I write as rule? Yeah, it will be to append a rule in the output table. Why? Because I'm going to do a query. So I'm going to generate a query. It's going to go out from me, for example, to PC 11. So it have to be added to the output table. So what should I add? So I want to filter the web traffic that go toward this network. But I want to still allow the access of the web server of PC2. So what should I write here? The destination, if the destination is 172.24.00/16, I want to drop them. If I just say that, it's going to drop all kind of traffic. So it's going to drop I will not have access to the secure shell server. I will not have access to the web server. I will not be able to ping. So what should I put? That the protocol is TCP. You know that HTTP is above TCP, isn't it? So this time I'm going to say the protocol is HTTP. What else should I do? For A. I didn't get the idea. So when we work with TCP, what are something that is, when we work with ICMP, we have type of messages. With HTTP, what do we have? We have port, source port and destination port. So do we want to filter a specific port, or we want to filter all the port? If I don't specify, I will filter all of them. But I want to filter a specific port. HTTP, a web server listens to which port? So look, we can ask, for example, here we have a web server. What command can I type to check in which port a web server is listening? So I can type netstat -numerical all TCP. Show me all the ports that are open for TCP. So the web server listens in port 80. Look, if I don't put numerical and I just put that, look, this is port 80. So for example, FTP is port 21, Secure Shell is port 22. But the people don't like to work like that. The people memorize a certain number of ports, like I do. And when we walk, we say, oh, we know that this is Secure Shell. We know that this is FTP. We know that this is HTTP. So here, as you can see, we did not install the telnet server. We did the same thing as we did it should have a telnet server. So if I want to install the telnet server, I do the same thing as I did last time, no? apt-get install telnet daemon. It is installed, but it's not started. So init d telnet. It's not started. How do I start it? Man telnet. Maybe I just checking I just can run maybe this command, and that will be enough to start the telnet server. Socket operation on non-socket. So I didn't want, okay, I don't want to spend too much time on that. Oh, it is open. It is there. Sorry. It is open also. Okay, it's why I did not want to start again. It is open. Okay, so what should I say here? If there is a web server and I sent a get message, the get message will have which source port and which destination port. So here I have a web client. it's called e-links. I could have Chrome, I could have Firefox. The thing that we don't have Chrome and Firefox is we don't have a GUI. So we install e-links, which is a basic text web client. So when I send a petition like a GET, I want to get a web page, for example, index.html. What will be the source port and what will be the destination port? What will be, you should know at least one of the two. What will be the source or what will be the destination port? So, the destination port will be what? Port 80, of course. If I have a web server listed on port 80, so the destination will be port 80. So see if I want to filter this traffic, I'm going to say if the destination port is 80. By putting that, I could put here HTTP, no? But I prefer to put 80. If the destination port is 80, what should I do? What action should I do? I'm going to drop this traffic. So the rule was written. So now from the firewall, I should not be able to access the web server in PC 11 and PC 31. So let's verify it. So I'm going to use e-link. So e-link to PC 2 still work. So let's verify it. And as you can see, say yes, it still works. So now I'm going to try e-link to PC 31. It should not work. You see, it's blocked. So it's intending at one point it give up and show me a message of error saying that it could not reach the web server in PC 31. Okay, it's intent a long time, but it will eventually drop. Let's wait to see. Okay, I'm going to Control C it. It doesn't work. And if I try to PC 11, the same thing, it doesn't work, as you can see. Now, if I try to PC 2, right away I have the answer. The web server did answer. This is the answer. This is the web page that you are requiring. It just have a header 1 and a paragraph. And it showed me the header 1 and the paragraph. Okay, that's fine. So now, as you can see, from the firewall, we cannot access the web server in PC 11 and PC 31. It doesn't mean that I block the traffic from PC 11 to the firewall. Okay, so let's go on PC 11 and we'll see that the people on PC 11 can still access the web server in the firewall. So let me write e-links. It will be long, but that's okay. Dump, so HTTP, the IP address, one of the IP address of the firewall is 192.172.24.01. So it's, as you can see, it's long. Let's make it shorter also at the level of this guy. So VI var www HTML index. So we are just going to put, this is an HTML. From this line to the end, delete. So this is the end of the HTML. Let's put a header 1. Let's put a header 1. Let's put 2 paragraphs inside. So let's copy something from the internet, something short. So for example, from JSU. Oh, from here, oh, we can access JSU here. So let's copy this paragraph. So here, College of Science and Mathematics, our college. And here, let's put something from the MIT, for example, mit.edu. Let's put that. Can I copy it? Hopefully, I will be able. It didn't let me copy it. Yeah. I don't even know where I am here. What is that? Okay. Oh, I know what I'm in the firewall. Yeah. So let's put just one paragraph. That's it. Huh? Otherwise, we lose a lot of time. And HTML. So from PC1, let me access the firewall again from PC11. And as you can see, College of Science and Mathematics, and we have the blah, blah, blah of the college. Okay, so I did access the web server from PC11. I can access the web server from the firewall. What we want to block is the possibility from firewall to access the web server here. Now, if from firewall, we want to block the access of the web server in PC2, we put a rule that is very similar. So what can we put? What will be the second rule that we need to put in the firewall? So IP table, this is output traffic. So I'm going to add in the output chain. What should I add? So when the destination is toward the network of PC2, which is 192.168.0.0/24, and the protocol is TCP, and the destination port is 80, I want to take the action of dropping those packets. So now if I look at this chain, it has two rules. Okay, so from the firewall now, I'm going to try with E-Link to access the web server in PC2, and I will not be able. So let's do a E-Link to PC2 this time, and as you can see, it's blocked. Now, it doesn't mean that I cannot secure shell to PC2. I can secure shell to PC2. So secure shell, let's put a user. I don't know the password of Amelia, so let me go back with John. And as you can see, it asks me the password of John. John pass, and I'm inside. PC2 as the user John. Let me exit. This is a remote session, and I come back to the firewall, as you can see. So I did filter the possibility of the users that are working in the firewall to access the web. They cannot access the web. They have to focus on their work. So some company will do that. Some company will say, okay, you have access to very few pages, which are the pages of our partners, because we know that you need to access the web page of our partner. So we allow you to access the web page of our partner, but any other pages are blocked. So JSU, of course, is open because it's a institution where we teach. But when you work as a cashier in a bank, you don't have possibility to serve the web. Okay, you have a computer and it just runs the application of the bank. And that's it, because this is why they pay you for, no? Okay, let's see the next exercise. I think it's time, but we are going to think about it before we leave. So look, block the web access from firewall to PC11. So previously I blocked the web access from firewall to the rest of the world. So now I want to block it from firewall just to PC11. Well, we can do that very fast. So let's do it. So I'm going to first flush all the rules. Verify that the rules, verify that the chain are flush. I flush all the chain are flush. Okay, there is no rule inside the chain. So I don't want the people here to access the web server. Maybe because this web server is dangerous. Or maybe it have things that I don't want the people to see. So that will happen in many communist countries. They don't want the people to see, for example, our web page. For example, Cuba filter most of the rest of the world. So the people in Cuba can just access a few web pages worldwide. They will access mostly the web page of other communist countries, but they cannot access the web page of the free world because there is too much information. So they will see that in the free world we have a lot of liberty, and of course they don't want the people to see what kind of liberty we have. So what can I do to filter the traffic, the web traffic from firewall toward PC11? But I should allow it toward PC2 and PC31. Just want to filter it toward PC11. So what will be? I'm in the firewall, I'm going to type a rule in the table. To inside which table I need to append a rule. Which chain, sorry. It will be the input chain, the output chain, or the forward chain. It will be the output, yeah. Because I'm going to send a GET to the web server. So the GET goes from me to the web server, so it's an output. Okay, what else? The destination that I want to filter is a specific destination, is 172.24.0.11. So you can let it like that. You can put /32. When you put /32, it's one IP address. Or you can put 255, 255, 255, 255. It's one IP address. Or you don't put anything. It's one IP address, just this specific IP address destination. Okay, which protocol? TCP. Which destination port? 80. For this packet, what action I want? I want to drop them. So now from the firewall, we are not able to access the web server that is in PC11. So let's check it. elinks --dump http 172.24.0.11. No answer. As you can see, it will take some time before it's given. Now, if I go against 31, which is PC 31, I have an answer, and the answer is from PC 31, as you can see. And if I go against PC 32, PC2, sorry, which is 192.168.0.2, I have an answer from PC2, as you can see. I am in JSU. So as you can see, we filter the possibility of the user that are here to access the web server in PC11, but we do allow the traffic to the other web server. Okay? Okay, so I think it's time. So let's stop here. I'm going to put more exercises. So I'm going to add other exercises, and I'm going to update so what we have in the web, so you can work on thinking on other exercises we are going to be a little more specific about TCP. Do you know how TCP works? Have you heard about the three-way handshake? So try to Google what is the three-way handshake, and we will capture it next time and work with the three-way handshake of TCP. Okay, I see you next week. I see you in today, sorry.